So first, definitely everybody need to understand. So the definition for the probability. So the formula is very straightforward, but definitely you need so fully so remember this formula. So the next part talk about a number over so another number. So bottom one is nothing but so the total number of equally so likely outcomes. So that is our so bottom number. So top number is nothing but so number of minimum condition as outcomes. So let's call this as meet my so condition. So remember this formula. So also always remember those two words so equally likely. That's what I mean. That means if you find the so outcomes are not equally likely, so first you need to make sure so change this one to equally likely and then solve problem from there. That is something definitely super important. So another thing is always remember the probability is always between so 0 and 1. So including 0 so and 1. So it's always between those two numbers. So if you get a 0, that means what? It's impossible to happen. So for example, if you flip a coin, so you want to get a chicken, of course, the probability is 0. So how about probability equals 1? So basically this means what? This is for certain to happen. For example, if you roll a die, you get a number less than 100. So definitely is the probability equals 1. That means guaranteed to happen. Of course, any number must be between 0 and 1. So that is something so super important. So another thing is definitely is you need so realize. So talk about probability problem. It's nothing but two counting problem. So something super so important. So if you look at the top part and the bottom part, so they all about so counting problems. So that imply if you know counting problems well, you should have no problem with probability problem. So next one, last time I talked about a few strategy to figure so mean my condition. So definitely you need fully understand so the following so common method to help you figure out how to meet my condition. So first one, so very common strategy is definitely you can check outcome so one by one and see so if it's satisfied and meet my condition. So another one is definitely so instead of check one by one, you try to construct the solution to figure out how many outcomes meet my condition. That is another super common way. So another thing is always remember. So sometimes so when we talk about even number, odd number, for example, even product, odd something like that. So the parity probably definitely is something so super useful to help you solve this kind of problem. So another thing is always remember. So sometimes it's hard to figure out so the right answer. So because there are so many so right answer. So if you see that situation, so the best way is you might think of so complementary counting. So complementary counting idea is nothing but so figure the total and then subtract wrong answers. A lot right answer imply there are only a few wrong answers. Definitely help you so simplify the problems a lot. So make sure I understand so everything so I cover here. So next one I will pick a few problems from last homework. Let's select problem 15 from last homework. So it's nothing but a dice problem. So it's a very so common problem. So roll a pair of dice. So let's try to solve the following so probability problem. So first one. So what are the probability? The sum is equals 6. So what are the probability? Sum equals 6. For this problem, of course, we have so two options. You can choose a check one by one, or of course, you try to construct a solution. I'm going to explain so both ways, so because both ways are super common. So if you want to check one by one, so definitely is you don't want to list so total 36 pairs. You want to list by this way. So because we have two dice, of course, let's try to write all the numbers for the first die. Of course, could be 1, 2, 3, 4, 5, 6. For the second die, of course, number could be 1, 2, 3, 4, 5, 6. When you check all these, pick a number from top one, any so pair up with any single number so down in the second row. For example, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, and then continue with first number is 2, of course, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, and then continue. That way, definitely we end up with a total 36 outcomes. Let's quickly check one by one. So clearly, as 1, 1, so cannot add together to the 6. As 1, 2 is 3. So definitely that'll work. 1, 3 is 4. So clearly, so if you check, we find 1, 5. So minimum condition. That means what? There are only one way if the first number equals 1. So satisfy our so condition. So next one, how about, so first number is 2. It's very clear. As 2, 1, that'll work. 2, 2, 2, 3, that'll work. Until you find 2, 4, so definitely add together as equal to 6. So 2, 5, 2, 6, definitely that'll work. That means what? Definitely we have one way if the first number equals 2. So continue, of course, if you check for 3, definitely you will find another one. So how about 4? Definitely, so based on let's see about 3 and 3. So of course, if you try first number 4, definitely we have a 4, 2. We have another one. So how about 5? If first number is 5, of course, after you check, we have only one based on 5, 1. So minimum condition. So how about 6? So clearly you cannot find anything. So minimum condition. So clearly we have total 5. So minimum condition that give us. So top number is 5. We know bottom number is nothing but total outcome. As clearly they are 36. Of course, that give us answer is nothing but 5 over 36. So let's see how to solve this one by the second method to construct the solution. Again, we know the total outcome is 36. The only thing we need is try to figure so minimum condition fast. Construct solution for this problem definitely is work faster than check one by one. Let's quickly try to construct all the possible solutions. So if the first number equals 1, it's very clear. Next number so must be equals 5 because we need sum to the 6. That means what? We already find so 1. So next one, how about first number is 2? Of course, 2, 4 definitely works. How about 3? Of course, 3 is 3, that'll work. So next one, 4, of course, 4 plus 2, that gives us 6. So next one, how about 5? Of course, 5 plus 1 equals 6. If you try 6, so definitely 6 plus 0 because 0 is not a die number. That means what? Definitely that doesn't work. That means what? Clearly we have 5 outcomes, minimum condition. So of course, total outcome is 36. Still, we end up with the same answer. So notice I solved this problem by 2 different methods. One is check the outcomes one by one. Another one is try to construct solution. Actually, both methods are super common when you solve so this similar problem. Let's see. So problem B. So what are the probability? The first number is greater than the second number. So let's see. So what are the probability? First number is greater than the second number. So still we have 2 methods. You can check one by one. So of course you can try to construct solution. For this one, let's try to construct solution. Definitely the next one you check one by one. So let's see. I'm going to solve this one by constructing a solution. So if you try first number equals 1, because first number greater than the second one. So definitely we cannot find anything. So minimum condition. So how about first number equals 2? Of course 2, 1. So definitely works. That gives us 1. So how about first number is 3? Of course, 3, 1. Of course, as 3, 2. So definitely works. So how about first number equals 4? Of course, could be 4, 1, 4, 2, 4 as 3. Actually, at this point, definitely you already figure out the pattern. So clearly, this is nothing but give us what? This is give us 1 way. This give us 2 ways. Of course, this give us 3 ways. So minimum condition should be 1 plus 2 plus 3 plus 4 and plus 5. So let's quickly verify. So last one is 5 or not. If the first number is 6, of course, could be 6, 1, of course, 6, 2, 6, 3, 6 and 4, and 6 and 5. It's very clear. We do end up with 5. So minimum condition. If the first number equals 6, that means what? The pattern definitely works. That gives us a total. So outcome, of course, we know is 36. So minimum condition is nothing but 1 plus 2 plus 3 plus 4 and plus 5. Of course, that end up with nothing but 15. Of course, it's very clear. That gives us what? So simplify, then divided by 3, that gives us 5 over so 12. That is answer for this one. So make sure you add this one. Let's see, the total outcome is still 36. The only thing is we try to figure so mean my condition. So sigma meet my condition. So meet my condition is not sigma. So first number is greater than the second number. So use your imagination. So how about how many outcome satisfy first number is less than the second number? So it's very clear. This number and this number must be same. First number is from 1 to 6. Second number is also from 1 to 6. The number of outcomes so satisfy first number is greater than the second one. So must be same as the first number is less than the second one. So that means what? The phrase we have this number must be same. Another situation is so first number equal to second one. So first one equal to second one. It's very clear. We have only 6. So nothing but 1 1 2 2 3 3 4 4 5 5 6 6. That means what? This is super easy to figure. So first number equal to second number is nothing but 6 outcomes. We know total we have 36. So now of course subtract this 6, we have only 30 left. We know this number must be same. That means what? This one must be 15. This one must be 15. That clearly give us minimum condition is nothing but 15. So remember this idea so could help you solve the problem faster. So problem C, the wanted probability. So the sum is even. Whenever you see the sum differs a product as even or odd, so definitely you need sigma, so sigma the parity property. So that's could be super useful to help you solve this kind of problem. So sum equals 7. Actually, we have only 2 case work satisfy this condition. So even number and a plus even number. So second one is odd number and a plus odd number. So if you see the first number is even, and in case a second number is also even, add together, so definitely the end number is even sum. If you get the first number is odd, of course, and this second number is also odd, of course, add together, so must be give us even sum. Let's quickly figure how many ways. So for the first case work, that means what? First number is even, it's very clear. 2, 4, 6, we have 3 ways. So second number is also even, it's very clear. 2, 4, 6, we have 3 ways. But definitely you need to understand this is a multiplication because what? So sigma we need 2 numbers. So whatever you get one number, that is nothing but 1 step again. So sigma you want to eat 2 so cupcakes. So if you only finish 1, that is 1 step. Because you need 2, so if you get here, now it's nothing but, we do know this is a nothing but a multi-step process. So clearly, first step we have 3 ways. So next step we have 3 ways. Multiply together, they give a total also 9 ways. Similarly, second one is nothing but 3 times 3. Of course, we end up with also 9 for the second case work. Now definitely we end up with minimum condition is nothing but 9 plus 9 because we have 2 case work here. They all works. They are different ways to meet my condition. Of course, that give us addition and nothing but follow a principle of addition. Minimum condition nothing but 9 plus 9, which is 18. Of course, total outcome is 36. So simplify, the answer here is nothing but a half. That's how you solve this one. So problem E is try to figure what the probability the product is even. So product is even. So if you get a product even, so definitely, so still you need sigma, the parity. So sigma even times even times odd is even, odd times even is even. So we find so 3 case work here. But we know the wrong answer, basically what is product is odd. We have only 1 case work for the wrong answer. So that means what? Definitely you need sigma complementary counting. So because what? Wrong answer, we have only 1 case work. Definitely it's much easier to figure wrong answer. I'm going to solve this problem by so parity and then plus the complementary counting. We know the total outcome is nothing but 36. Of course, total outcome is 36 and it minus wrong answer. Wrong answer is nothing but, of course, a product equals odd. So how to get a product equals odd? It's very clear. So first number must be odd, and second number is also must be odd. Of course, we have 3 ways. So in the first step, of course, we have 3 ways. In the second step, multiply together. That means what? We have 9 wrong answer, which give us odd product. This minus the 9, and this simplify. So definitely we end up with answer is nothing but 3/4. That's how you solve this one. So in a so better way. F is what the probability product is odd. So because all the numbers are from 1 to 6 multiplied together, either odd number or even number, nothing more. So what that means the probability as a product equals odd. Any plus a probability product is even must be equals 1. We already figure the probability for the product is even is 3 over 4. That means this answer must be equals 1 over 4. So 3 over 4 plus 1 over 4, that gives us 1. Let's quickly solve this one to match this answer. So product is odd. Of course, we know total outcome is nothing but 36. So product is odd. Actually, we have only one case work for this one. So nothing but odd number and multiple with odd number. So clearly, first step we have 3 ways. So next step we have 3 ways. Of course, multiply together. We have 9 minimum conditions. So that means what? The answer should be 9 over 36. So simplify, we end up with 1 over 4. Figure what the probability the product is. Product is a perfect square. So a perfect square. Let's see how to solve this one. So definitely you need to understand this problem. So could be very, very important. So still we know the total outcome is nothing but 36. The key is try to figure how many minimum conditions. So that give us the total is 36. So all we need to try to figure how many minimum conditions. So to figure the minimum condition, I'm going to show you how to solve this one by those 2 methods. Check one by one. Or of course, you can try to construct solution. So let's try to finish this problem by both ways. So you can choose either one as you like. So if you try to check one by one, you need write. So the first number is nothing but could be 1, 2, 3, 4, 5, 6. Next number, of course, could be 1, 2, 3, 4, 5, 6. Let's quickly pair up and check one by one. So of course, 1 times 1 definitely is a perfect square. That gives us 1. So 1 times 2 is 2. So definitely not. 1 times 3 is not. 1 times 4, of course, 4 basically is 2 times 2, which is a perfect square. 5, 6, not. That means what? If the first number is 1, we find 2 as a minimum condition. So how about 2? Of course, 2 times 1, that is 2. 2 is not a perfect square. 2 times 2 is perfect square. 6 is not. So 8 is not. So 10 is not. 12 is not. That means what? We have only 1 minimum condition if the first number is 2. So how about 3? Of course, 3, 1 definitely doesn't work. 3, 2, which is 6, no. 9, so 3, 3 definitely works. So 12, no. So 15, no. 18, no. That means what? We have only 1 if the first number is 3. Check 4, of course, 4, 1 multiplied together 4. So definitely this is a perfect square. So next one, of course, 4, 2 doesn't work. 4, 3 doesn't work. 4, 4 is 16. 16 is perfect square. So of course, 20, 24, no. That means what? We have 2. So minimum condition if the first number equals 4. Let's quickly check 5. Of course, multiply together 5, no. 10, no. 15, no. 20, no. 25, yes. 30, no. That means what? We have only 1 minimum condition if the first number equals 5. Let's check 6. Of course, multiply together here is 6, no. 12, 18, 24, no. 30, and 36. Of course, we know 36 is a perfect square. That means what? Definitely we have 1 minimum condition if the first number equals 6. Quickly add everything up. Here is 4. Of course, here is another 4. That means what? Total we have 8 minimum condition. Simplify, divided by 4, divided by 4. That gives us nothing but 2 over 9. That is answer for this one. So I'm going to quickly show you another way to solve this one. Basically, try to construct solution. So usually, if you see the number has clear pattern for this one, of course, 1, 2, 3, 4, 5, 6 for each number. So clearly, we see the pattern for each one. Usually, if you see the clear pattern for each number, so the better way is try to construct solution. So usually, this method works better than check one by one. But if you cannot see the clear pattern for numbers, so usually check one by one is better. Practice more, definitely you get that sense. So I'm going to show you how to solve this one. So by construct solution. Let's try to figure the possible perfect square. Of course, could be 1. So next perfect square could be, of course, is 4. So next number is 9. So next one, 4 times 4, which is 16. Next one is 5 times 5 is 25. So next one is 6 times 6, which is 36. So no more, because what? So clearly, the larger possible is 6 times 6, which is 36. So clearly, we cannot find anything more. So now try to construct a solution for each perfect square. How about 2 numbers multiplied together equals what? Actually, we have have only one way, which what? 1 times 1. So how about two number? So from 1 to 6, multiply together equals 4. Of course, could it be what? Could it be 1 times 4? Could it be so 2 times 2? Of course, could it be 4 times 1? Notice 1, 4 and 4, 1 are different. So definitely you need to understand. So 1, 4 and 4, 1 are different. Because what? Because first number equals 1, second number equals 4. Definitely is different from first number equals 4, second number equals 1. So clearly, so they are different. How to get so 9? Of course, could be 1 times 9. So definitely that'll work. 3 times 3 definitely is 1 right answer. So next one 9 times 1 definitely that'll work. How about 16? Of course 116. So clearly that'll work. All those two numbers must be between 1 to 6. So that's why so we cannot have 1 multiplied with 16. So next one 2 times 8. So same reason. So that'll work. So next one 4 times 4. So definitely that give us one right answer, which is 4 times 4. So next one 82. Of course 61 that'll work. How about 25? 1 times 25. So that'll work. So next one 5 times 5. So definitely they said okay. So next one 25 1. So definitely that'll work. How about 36? 1 36. No. 2 18. So no. 3 so 12. So no. 4 9. So no. Of course next one is 6 6. Of course, 6 and 6. If you track, for example, 9, 4, definitely is same reason as that'll work. So that means what? We have 1, 2, 3, 4, 5, 6, 7, 8. So definitely we have 8 minimum condition. We have total 36. We end up with 2 over 9. So make sure you understand how to solve this kind of problem. So next one is H. So what are the probability? The product is greater than 10. Of course, we know the total outcome is nothing but 36. The key is still try to figure so minimum condition fast. You can check one by one, or you can try to construct solution. Of course, for this problem, you might think about the complementary counting. Because so I feel we should have a lot of numbers multiplied together greater than 10. So greater than 10. I'm going to show you so how to solve this one by checking one by one and complementary counting. I'm going to show you both methods so to solve this one. So still, if you want to track one by one, let's try to list everything here. So first number could be 1, 2, 3, 4, 5, 6. So next number, of course, could be 1, 2, 3, 4, 5, 6. Let's quickly check. So multiply together greater than 10. So of course, if first number equals 1, multiply with so anyone here so must be less than 10. That means what? Definitely we have no so minimum condition. So how about first number 2? Of course, it's very clear. So far they all feel even 2, 5, which are 10. 10 is not greater than 10. They give us only one is 2 times 6. A for the first number equals 2. So how about 3? Of course, those 3 that work. Clearly, those 3 works. That give us, we have, so 3 so minimum condition. A for the first number equals 3. So how about 4? Of course, up to here, so that'll work. Of course, definitely we have 4 so minimum condition. So how about 5? 5 multiplied 2, which is 10. 10 is not greater than 10. So that gives us 1. So definitely we have only 4 so minimum condition here. How about 6? Of course, so 6, 1 that'll work. Everything else works. That means we have 5 minimum condition. So A for the first number equals 6. Quickly add everything up. That give us, of course, 4. Of course, we have 8 here, which is 12. Of course, 12 and plus 5, that give us nothing but 17. So meet my condition. Final answer here is nothing but 17 over so 36. So if you think about the complementary counting, so that means what? We try to figure bottom number is 36, top number is nothing but 36, and then minus 1. Minus wrong answer. So be very, very careful. Wrong answer is what? Is a product less equals 10. So don't miss equal here. Don't miss equal here. So because here we have greater. So that means what? Wrong answer must be less equal. If here is greater equal, wrong answer is less only. So don't make this a mistake. So definitely you need to get this step right. Let's try to construct solution for this one. So clearly, if first number is 1, of course, very clear. 1, 1, all the way to 1, 6 works. So simple 1, 1, all the way, so 1 to 6, definitely 1. That give us, 6 wrong answer. How about first number is 2? Of course, 2, 1, all the way what? So all the way to 5. So all the way to 5. Base what? So 2, 5 is multiplied together, still less equals 10. That means what? Definitely give us 5. So how about first number equals 3? Of course, 3, 1. Of course, 3, 2. And all the way to 3, 3. So next one is 12. Definitely what? Is not satisfied. This wrong condition with the product less equal 10. That means what? Definitely we have only 3 here. How about first number 4? Of course, could it be 4, 1 and 4, 2 multiplied together less equal 10? That gives us 2. So how about 5? Of course, 5, 1 and 5, 2 multiplied together and less equal 10. We have 2 here. So how about 6? Of course, we have only 1, 6, 1 multiplied together less than 10. That means we have only one wrong answer. A for the first number equals 6. Quickly add everything up. So I do notice this one. This is give us 10. Of course, here is 19. So look at here. We have 19 wrong answer. So what that means we have more wrong answer. Clearly, at this point, we should realize the best way is nothing but check one by one all short solution. So not by complementary counting, but still we can think about that direction. So of course, simplify is nothing but give us same answer, which is 17 over 36. So end up with the same answer. So make sure you understand this one. So I'll quickly put down the problem. So basically we have 2 wheels. So our first wheel is nothing but give us what? 3, 5, 8, 4. We have 4 equally likely numbers here. Notice equally likely. So next one is also we have equally likely number. But we do notice we have 3 only. So 6, 9, and 7. So let's try to solve the following problem. First one, let's try to figure what the probability the sum is even. And let's try to understand how to figure what the probability sum equals even. Sum is even number. So this problem looks different from last dice problem. Actually, this is another problem very similar to the dice problem, because what? Basically we have 4 numbers. In the first number, second number we have 3. So basically what? Second dice problem we have 6 equally likely number. In the first one, 6 equally likely numbers in the second one. So here only difference what? We have different number of numbers, and also the numbers are different, but the idea exactly the same. That's why they are the same type of problem. So if you understand the dice problem, you should have no problem with this one. So let's try to figure, quickly figure, total outcome. Because the first step, we have 4 ways. Next step, we have 3 ways. For each, they are equally likely. That means what? Total outcome is nothing but 4 times 3. This is consistent with, dice problem, we have 6 times 6. So here we have 4 times 3. So minimum condition, of course, definitely is you need to think about the parity property. Because we think about this is an even sum. Even sum. Basically, we have only 2 case word here. First number is even. Next number is even. Next case word is first number is odd. Next number is also odd. Let's try to figure how many ways. We have even number in the first one. Very clear. We have 2. And that means what? The first time we have 2 ways. So how about second one? It's very clear. I have only 1 even number here. That means what? Second step we have 1 way. Definitely you need to understand this is a multiplication. Again, this is a step problem. Why? Because we need 2 numbers. If you get only 1, that didn't reach our goal yet, because we need 2. Definitely you need to understand this is a multi-step problem. Of course, if you get here, 2 times 1 is nothing but give us 2. Second case work. First one is odd. It's very clear. We have 3, 5. That means still we have 2 ways. So how about odd number for the second number? It's very clear. We have 2. So that means 2 times 2. Of course, we end up with nothing but 4. Now we need add everything up. Of course, 2 plus 4. That give us 6 minimum condition. Of course, finally we figure answer here is nothing but half. That is answer for this one. Problem E. Basically trying to figure what the probability sum is greater or equals 12. Let's see how to solve this one. try to figure minimum condition by checking one by one. So why? Because I do notice, so those number has no clear pattern. If this one is 1, 2, 3, 4, this is what? This is a 1, 2, 3. I would rather try to construct solution. But here, clear the number has no clear pattern. That's why the best way is what? Definitely is not try to construct solution, is try to check one by one. We do notice we have only 12 outcomes. So create this. The first one could be 3, 4, 5, 8. So next one, of course, could be 6, and 7, and 9. Let's quickly check. Sum together greater equals 12. Clearly, so this doesn't work. This doesn't work. Of course, this works. That means what? If first number equals 3, we have one minimum condition. How about first number equals 4? This is 10. This is 11. This is 13. Definitely, we have only one. So how about 5? Of course, this doesn't work. Of course, clearly we have 2. How about first number is 8? Clearly, every number works. That means what? We have 3. So clearly give us what? Clearly, we end up with a 7 minimum condition. We do have total outcome is 12. That means answer is nothing but 7 over 12. That's how you solve this one. So what the probability? The product product is less than 50. So definitely I feel so there are a lot of case where out of the 12 meet this condition because what we deal with small numbers multiply together. It's hard to greater equals 50. They give us what? So definitely is you need sigma the complementary counting for this problem. We know total outcome is nothing but 12. So here I'm going to try to figure a wrong answer. Wrong answer is nothing but product is what? Greater equals 50. So make sure you get this one right. Last wrong answer is what? Greater equal. So don't miss this equal here. So still I'm going to list the number. So first one could be 3, 4, 5, 8. So next one of course could be 6, 7, and 9. So greater equal 50, there's no way you start with 3. So no way after 4. Of course, no way for the 5, because 5 times 9, larger possible is still less than this one. So how about 8? Of course, now be very careful. That give us product greater equal 50. This pair definitely give us a product greater equals 50. That means what? We have only two wrong answer. Only 2 wrong answer. That means what? Here is 2. Of course, they give us nothing but 10 over 12. So simplify, divided by 2, we end up with 5 over 6. That is answer for this one. So make sure you understand the best way to solve this one. So we have 2 wheel. So first one is 1, 2, and 3. So next one is 4, 5, and 6. So probably try to figure what the probability. Some is even. Let's see how to solve this one. It's very clear. So 1, 2, 3 are not equally likely because what? Because this number has a more area. Of course, clearly, as 1, 2 are equally likely, we have more chance to get 3. That means definitely they are not equally likely. If they're not equally likely, the first step is you need to make it equally likely, and then before you solve this one, so quickly divide this one into 4 equal area section. Of course, let's call this number 3. This number is 3. So definitely now those 4 numbers, 1, 2, 3, another 3 are equally likely. So how about 4, 5, 6 clearly are equally likely? That means what? Definitely they only give us a total outcome in nothing but 4 times 3. That give us 12. Sum is even. Clearly we have 2 case work here. So first number is even. So next number is even. So how about first number is odd? Next number is also odd. Let's quickly figure this one. First number is even. Actually, I see only only 1 in the first step. So next number is even. I see only 2 numbers. So of course, in the second step, we have 2 ways. So multiply together again. So this multiplication has nothing to do with this operation here. Addition, subtraction, or multiplication. Actually, they all end up with multiplication here. Because what? Because it's a multi-step process. That gives us what? In the first case where we have 2 ways. So how about first number is odd? It's very clear. So I see 1, 3, 3. We have 3. So second one, I see, so our number, we have only 1. Of course, I multiply together, and that's by 3. Of course, we need to add everything up because what? This is a casework, this is another casework. Casework by casework, you need to use addition. So of course, we find 5 minimum condition. Final answer here is nothing but 5 over 12. So make sure you fully understand this one. So a wheel, so this wheel is something like this. So basically 2 as 3 and 4, this is 1. The problem give us what? So we need do the experiment twice, get 2 numbers. Let's draw so this picture twice. So basically it's now easier to understand. Sigma. First will give us one number. Second identical will give us another number. So if you draw 2, it's easier to understand. So let's try to figure out A, B, and C. First problem. What are the probability the sum is even? What probability sum is even? Let's see how to solve this one. 1, 2, 3, 4. They are not equally likely. 2, 3, 4. They all equally likely, but not 1. So that means what? We need to divide this one into equal area. So by this way, of course, now we have 1, 1, and 1. 2, 3, 4. So now we have 6 numbers. They are equally likely. Do the same thing for this one. Of course, now we have 1, 1, 1, 2, 3, 4 in a second wheel. So now definitely those 6 numbers are equally likely. That gives us what? Total outcome is nothing but 6 at a time 6, which is 36. So try to figure a minimum condition. So base one. Sum is even. That means what? We have only 2 case work here. So first number is even. So next number is even. All first number is odd. Next number is also odd. Let's try to figure how many ways in the first step. So even. Look at here. I say only 2 and 4. That means what? We have 2 ways in the first step. So same thing, because the same way. That means what? First number 2, second number is also 2. That gives us what? 2 times 2 is nothing but 4. First number on, of course, 1, 1, 1 as 3. I see 4. Of course, second number is also 4. Of course, multiply together is nothing but 16. Of course, we need to add AC up. That gives us 20. So that gives us minimum condition is 20. Of course, now we need to simplify. Divided by 4, divided by 4. It gives us a 5 over 9. That is answer for this one. So make sure you fully understand. So problem B. So what are the probability we end up with an odd product? So definitely this sounds easy one because what odd product that implies we have only one case where first number must be odd and the second number is odd. We do know so the total outcome is nothing but 6 at a time 6. That gives us 36. Quickly figure so how many minimum conditions is nothing but first number is odd and multiple ways second number is also an odd number. First number odd, of course, we have 1, 2, 3, and 4. So definitely we have 4 numbers. Same thing for the second step. Of course, now we have 16. So minimum condition. Of course, 16 over 36 divided by 4 is nothing but give us what? 4 over 9. That is answer for this one. So next one, let's try to figure. So problem C is nothing but so what are the probability? So product is what? Is a perfect cube. Total outcome is nothing but 36. Let's try to figure minimum condition. So for the minimum condition, for this one, I'm going to check one by one because what I do notice those numbers so not in a clear pattern. So that's why the best way is let's try to check one by one. If you choose a check one by one, so definitely you want to write this way. The first number could be 1 and 1 and 1. Of course, 2 as 3 and 4. So next number could be 1 and 1 and 1. Of course, 2 and 3 and 4. So basically, of course, pair up that gives us total outcome. Instead of list 36 pairs, so definitely this one works better. So now quickly check one by one. So I'm going to put down all the possible perfect cube number, then make the checking easier. So this is a perfect cube. The first one is nothing but 1. 1 times 1 times 1, which is 1. So next one is 2 times 2 times 2, which is another perfect square, which is 8. So next one is 3 times 3 times 3. Of course, that gives us nothing but 27. So next one 4 times 4 times 4, which is 64. I'm going to stop here. Clearly, we can only have 16. That means what? So those two even those two are impossible. So definitely that make the calculation much more easier. So let's quickly check. So one multiple ways, of course, multiple. This one is okay. This one okay. This one okay. Of course, 2. So that give us 2. Doesn't work. 3 doesn't work. 4 doesn't work. That means what? A first number is 1. We have 3. So minimum condition. Of course, same thing for this one. So of course, same thing for this one. How about 2? Of course, so 2 multiple. This one doesn't work. Doesn't work. Doesn't work. Of course, multiple together 4, 6, 8. 8 is okay. That means we have 1 here. So next one, try to get 3 multiple ways each number. There's no way we end up with 1 or 8. That means 1. No way here. How about 4? Of course, 4 multiple ways. So 1 doesn't work. 2, they give us 8. 8 is a perfect cube. Of course, everything else that work. That means what? We have one way. So minimum condition A for the first number equals 4. So now add everything up. That gives us what? That gives us nothing but 11. So minimum condition. Final answer here is nothing but 11 over. So 36. So hopefully you fully understand. So that's one. So before I put out a few typical probability problem, so I do want to point out something super important. So always remember, so probability is nothing but two counting problem. So that's nothing but is nothing but about two counting problems. So of course, if you know the typical counting problems very well, that means what? You can either figure minimum condition, you can either figure so total outcome. Of course, to the ratio that give you the probability for this kind of problem. So always remember this idea again. So sigma probability is nothing but about two counting problem. So I'm going to quickly give you a few so very typical problem. I help you understand the strategy to solve the probability problem. So first one, so let's see. Fair coin flipped 5 times. So what are the probability? So we get exactly so 4 tails. That is our first example. So if we flip a coin 5 times, so what are the probability? So we have exactly so 4 tails. Let's see how to solve this problem. So definitely you need to understand the idea. Actually, what if you try to figure the total outcome? It's nothing but try to figure the outcome for this part. So imagine. So the total outcome is nothing but our first counting problem. It's nothing but this way. If we flip a coin 5 times, how many outcomes are possible? That gives us the total outcome. It's very clear. We know it's nothing but 2 to the 5th power. So for the top part, minimum condition, that is another counting problem. So think about this way. If we flip a coin 5 times, we want to get exactly 4 tails. How many ways are possible? Definitely we've done this kind of problem before. So how many ways? It's very clear. We know we flip 5 times, we want to get 4 tails. So that means what answer is 5C4 or 5C1. Of course, I want to choose a 5C1 because it's easier to evaluate, but they are exactly the same. So quickly evaluate this one. Of course, any number C1 is nothing but that number. Of course, 2 to the 5th power is nothing but 32. That gives us answer, which is 5 over so 32. So make sure you fully understand the idea. Again, think about this nothing but 2 counting problems. It's nothing but 2 counting problems. So from here, flip a coin 5 times. How many ways are possible? That gives us the total outcome. So next one, flip coin 5 times. We get exactly 4 tails. So how many ways are possible? That give us minimum condition. Solve those two. Counting problem. Of course, do the ratio. That is answer for the probability. That is idea. Think about we have 4 boys and 3 girls. We want to select 2. So at random, what are the probability, including 1 boy and 1 girl? So think about. So we have 4 boys and 3 girls. So we want to select 2. So at random. So what are the probability? So including 1 boy and 1 girl. Let's see how to solve this one. Again, this is nothing but 2 counting problem. So first one is so sigma. We have 4 boys and 3 girls. So select 2 at random. So how many ways are possible? So that is our first counting problem. This one gives us a number of total outcomes. So total outcome is nothing but from this counting problem. We know the answer is nothing but, of course, combine everything together, which give us 7. Of course, we want to choose 2. That give us is nothing but 7 and C2. So how to figure minimum condition? That is another counting problem. So sigma, we have 4 boys and 3 girls. We want to select 2, including 1 boys and 1 girls. How many ways are possible? It's very clear. This is our standard, typical forming a community problem. It's nothing but 4C1 and multiple ways as 3C1. That give us nothing but 4C1 and multiple ways as 3C1. Let's quickly evaluate each one. Of course, any number number C1 is nothing but this number. That means this is 4, this is 3. Of course, multiplied together is nothing but 12. Let's see how to evaluate a 7C2. 7C2 is nothing but 7P2 and it divided by 2 factorial. So 7P2 is nothing but 7 at times 6. Of course, and it divided by 2 factorial is nothing but 2 times 1. So simplify, this is nothing but give us 21. So simplify, divided by 3, that give us final answer here is nothing but 4 over 7. That is answer for this one. Okay, this is a point A, this is a point B, the point C is so down here. This is a point C. Choose a shortest path, shortest path at a random. So if I choose a shortest path at a random from A to B, so let's try to figure what the probability pass through the C. So definitely again, this is nothing but 2 counting problem. First one is nothing but try to figure the shortest path from A to B. How many ways are possible? That give us nothing but the total outcome. Let's quickly figure so how many shortest paths from A to B. So everything together. So clearly, shortest path from A to B, so every single one, so include 3 east and 4 north, of course, different order, that give us the different shortest path. But still, we end up with, it must be contain, 3 east, 3 east and 4 north. Now this is nothing but generalized permutation combination problem. The total answer is nothing but 7 factorial and it divided by 3 factorial and it divided by 4 factorial. Because 3 plus 4 equals 7, that's why it's nothing but 7 C3 or 7 C4. They are equal. That gives us the total outcome is nothing but 7 and C3. So next one, how to figure the minimum condition. Minimum condition is actually what is another counting problem. So sigma I put this way. So how many shortest paths from A to B passing through C? So clearly this gives us another standard counting problem we done before. And also this answer is nothing but our minimum condition. A minimum condition from A to B passing through C and also must be the shortest path. It's very clear. We need 2 steps. So first step is from A to C. It's very clear. 2 east and 2 north. So of course, that give us 4 factorial divided by 2 factorial divided by 2 factorial is nothing but 4 C2. From C to B, of course, 1 east and 2 north. So clearly give us 3 factorial divided by 1 factorial divided by 2 factorial. So that give us nothing but 3 C1. Let's quickly evaluate this one. 4C2 is nothing but, of course, 4C2 is nothing but 4P2 and then divided by 2 factorial. 4P2 is nothing but 4 times 3. Of course, 2 factorial nothing but 2 times 1. Simplify here is nothing but 6. Of course, 3C1 is nothing but 3. So let's try to figure 7 and 7 and C3. 7 C3 nothing but 7 P3 and then divided by 3 factorial. Of course, 7 P3 nothing but 7 times 6 and times 5. So starting with 7, we need 3 numbers. Of course, we have 3 numbers here. 3 factorial nothing but 3 times 2 and times 1. Of course, simplify 3, 2, 1. Simplify with 6. Of course, top number is nothing but 35. Bottom number equals 1. That gives us what? So total outcome is nothing but 35. Of course, final answer here is nothing but 18 over 35. That is answer for this one. So make sure you fully understand. So imagine we have 4 people, so A, B, C, and D. They want to sit a round table in a circular permutation fashion. So what it means, if everybody make a rotation, will not generate a new answer. Remember the difference between the permutation and circular permutation. So we have A, B, C, D. So they sit down in a circular permutation. So a circular permutation fashion. Let's try to figure out what the probability. So A and B so next to each other. Let's see how to solve this one. For this one, still we have nothing but 2 counting problem. So base one, first one is if A, B, C, D so sit around a round table in a circular permutation way. So how many ways are possible? There's nothing but our total outcome. So we have 4 different objects. Of course, we know the circular permutation answer is nothing but number of objects decreased by 1. And then do the factorial. Of course, sigma this is 4. Of course, that gives us nothing but 3 factorial. So let's try to figure the minimum condition. For this one, minimum condition, so I'm going to try to list answer. Also, always remember, when you solve the circular permutation problem, the best way is always remember, try to fix one object. This is something super important. After you fix one person, now of course, that person is gone. We do our standard permutation for the rest. That is our answer. So always remember, this is a beautiful idea. So fix on one object. I'm going to fix A here. So because the problem talk about A, B are next to each other. Simple, we have 4 chairs. So A must be seated here. So of course, so do the permutation. Of course, 3 chair. So standard permutation at this step because one number is gone. That gives nothing but 3 factorial. So minimum condition is what? A, B are next to each other. Of course, how about B is here? Of course, could it be what? Could it be CD or DC? That give us 2 answers. So of course, B could be here. So they are default. Of course, could be CD and DC. So that clearly give us what? Give us a 4-way minimum condition. So simplify here, nothing but 4 divided by 3 times 2 and times 1. Of course, final here is nothing but 2/3. That's how you solve this one. Again, the key is fix one person. If you want to solve circular or permutation problem, that is something super important. So I'm going to show you another beautiful idea. So definitely there's nothing wrong with my last solution here, but there is a much better answer. So still, I want to fix A is here. Let's try to figure if A is here, what are the probability so A, B are next to each other? Because A is already here. Let's try to figure B can be where? Of course, B can be here, here, or here. B have 3 choices. So how many ways are minimum condition? Of course, here is okay, here is okay. That give us what? 2 out of 3 so minimum condition. That give us what? Probability nothing but 2/3. But it's the same answer as last solution. So clearly, if you understand, this one is much better. So make sure you understand this one. So simple, we have circle. The radius is 4. We have a small square, side length equals 1. So imagine if I put through a dot at random base 1. So given all field inside this circle, what are the probability the dart hit this square? That is our very typical geometric probability problem. Let's see how to solve this one. So clearly this time we cannot list answer anymore because what? The point this dart could be here, could be here, could be any point inside this circle. Of course, minimum condition is what? Any point inside this square. So sigma any point inside a geometric figure. So definitely this is something to do with our area. So that's why this is nothing but, so we try to figure the probability. So probability is nothing but what? Total outcome is what? Is every single point inside this circle is nothing but the area of this circle. That gives us a total outcome. So area is nothing but pi. Of course, r square is nothing but 4 alligator square. So top part is what? So every single point inside this square, that means my condition. Every point inside that square, it's very clear. Talk about the area of that square. Of course, side length multiplied by side length, that gives us what? Clear, that gives our final answer here is nothing but 1/16 pi. That is answer for this one. Make sure you understand. So this one, let's quickly do a one in class practice. This is our first wheel. This number is 1, 2, and 3. We have another. We have another wheel. The number is 4, 5, and 6. So we select one number at random from first one. Select another one from a second one at random. So problem is what the probability the product is even. What the probability the product equals even number. Even number. That is our first one. So next problem. So we have 3 boys. 3 boys and 3 girls. We want to select 2. At a random. At random. So what are the probability, including 1 boy, 1 girl? That is our second second problem. So next one. We flip a coin, flip a fair coin. 6 times. 6 times. What are the probability? We get more heads. Than tails. First one, it's very clear. So those 3 numbers are not equally likely. We need make equally likely before we solve this problem. So definitely is we divide this one into 4 equal area. So same thing for here. They are not equally likely. Of course, we need to divide into 4 equal area. That gives us now we have 4 equally likely number. So if you make both number are equally likely, that gives us total outcome is nothing but 4 times 4. That gives us nothing but 16. So minimal condition, so product is even, definitely want to think about complementary counting. So total is 16 minus wrong answer. Wrong answer is nothing but so odd product. So let's try to figure. So how many ways we end up with odd product? In order to get an odd product, first number must be odd, second number must be odd. So let's try to figure how many ways in the first step. I see 1, 3, 3. So that gives us 3 ways. So in the first step, that end up with odd number. So let's see how many ways in the second step we end up with odd number. I see only 1. That gives us what? 3 times 1. We have 3 odd product. That means wrong answer is nothing but 3. Of course, that gives us 13 over. So 13 over 16. 16 minus 3 wrong answer. That gives us 13. Of course, simplify this is our final answer, which is 13 over 16. So this is a very typical probability problem. So it's nothing but talk about 2 counting problem. So total outcome is nothing but so sigma we have 3 boys, 3 girls. We want to select 2 at random. How many ways are possible? It's very clear. Combine everything together. That give us 6. Of course, choose 2. That give us nothing but 6 and choose 2. So minimal condition, that is another counting problem. So sigma we have 3 boys and 3 girls. We want to select 2. How many ways include 1 boys, 1 girls, exactly. That is our standard counting problem. And nothing but 3C1 multiple ways 3C1 3C1 multiple ways 3C1. Quickly simplify. Top is nothing but 3 times 3. Of course, bottom one is of course 6C2. 6C2 is nothing but 6P2 and divided by 2 factorial. 6P2 is nothing but 6 and multiple 5. Of course, bottom one is nothing but 2 times 1. So simplify here is nothing but 15. Of course, that gives us total outcome is 15. Of course, simplify. So that gives us nothing but 3 over 5. That is answer for the second one. Let's see how to solve the last one. Still, this is nothing but 2 counting problem. So total outcome is nothing but flip a coin 6 times. How many ways are possible? It's very clear. That gives us nothing but 2 to the 6 power. So minimal condition is nothing but sigma this way. Flip a coin 6 times. So how many ways we get more heads than tail? So definitely we need to do the case work because we don't know how many heads and how many tails exactly. So first one is of course could be 4 heads and 2 tails. Definitely we have more heads than tail. So next one could be what? Could be 5 heads, 1 tail. Of course another case work could be what? Could be 6 heads, 0 tail. That's all we have for minimal condition. So for each one, it's nothing but a very standard counting problem. So we flip 6. Of course, you can choose either one to get answer for this one. I'm going to choose this one. That give us 6 and choose 2. Of course, this one is you can choose either one. I'm going to choose this one because this number is smaller. Of course, you can choose either one. You'll get the same answer. I'm going to choose 0. Quickly evaluate this one. Any number C0 is nothing but 1. Any number C1 is nothing but that number. So 62. We just figure out this is nothing but 15. Of course, that gives us total minimal condition is nothing but of course adding together is nothing but 22. Of course, we know 2 to the 6th power is nothing but 64. Top number is 22. Simplify. Final answer here is nothing but 11 over 32. That is answer for this one. So let's stop here.